So it's not like you can just go off the shelf and buy a new, 50-to-1 reduction gear or whatever. All right. So let's continue on with today. All right. Any questions before we kind of move through the rest of this theme cycle? No? Okay, good. All right, so just to review quickly, we're going from the main condenser. This is coming off of our low pressure turbine. All right, our steam is passing through our seawater. All right. Our seawater goes directly overboard. And remember, we have our main circulating pump, but we could also utilize a scoop that will bring in salt water. All right. And then we have this little, basically, container in the bottom of the main condenser that is going to be filled with a level in it. And we're going to try and maintain that level so we don't have pumps that run dry. All right, we have main condensate pumps, and they're going to be moving all of our feed water from here on out. So where are the main condensate pumps located in our vessel? Where are they located?
Lower engine room.
Where in the lower engine
room? Beneath the condenser.
Beneath, kind of, but not really.
It's gonna be right next to the AC components.
They're not next to the air conditioning. We'll pull up a picture in a second. So this is my nice drawing of the engine room. All right, so this is lower engine room. All right, we have aft, port, starboard, and forward. All right, AMS is forward. Here is our door to the lower engine room right here. All right, here's our staircase. We have our main condenser. All right, here's our thrust bearing, and this is our main shaft. All right, we have two auxiliary condensers up in the air. All right, and we have our feed pumps and then our import feed pump. So where is it located? And then this square area is just a walkway. So we have our main condensate pumps. Where could they be located? They're probably going to be located somewhere near the main condenser. They're not going to be directly underneath it, but they are going to be damn near close. Because if they were directly underneath, that would be very hard to operate them or do any maintenance. All right, so they're going to be located right about here. All right, so that's where your main condensate pumps are. They're going to be taking lines directly out from the bottom of the main condenser. All right. So let's keep going through. So we now have feed water at this spot. All right, and we have our air drag line that's going to the main air ejector. So we go to our main air ejector. Two things are happening. One, we have our condensate from our main condenser coming in. All right. And two, we have both of our air ejectors, our jet pumps, that are going to be receiving 150-pound auxiliary steam, and it's going to be dragging any of the non-condensables in. All right. We have two sections. All right, there's a wall here that's going to separate the two sections of our air ejectors. All right, and we are basically going to be taking, and we're going to return any of the steam. Basically, it's going to condense any of the steam, and it's going to return it to the condenser via a loop seal. All right, since we're going to be utilizing this auxiliary steam, but then we need to re-drag out that air, that non-condensable air that's going into another air ejector. right? And that's going to drain to an ADT. And a non-condensable, so it's going to blast out of this air ejector, this air vent over here. All right, we have an inner condenser. We have an after condenser. They exist at 2 different pressures and or vacuums. This one's at 10 to 15 inches of mercury. The other ones are around an atmosphere. All right. Now, this main air ejector is not original to the vessel. Does anybody have any idea what was used before this? What did we use? And this wasn't retrofitted when we got it as a ship. This was retrofitted pretty quickly after the ship was built. The pumps, well, one of them still exists on board the ship. It's not used for anything with the main steam cycle, but it is used. So what were the original pumps that were put in place besides the main air ejector? What could we have used? All right, we used basically some vacuum pumps. All right, we had 2 of them. Now, these vacuum pumps, why would we replace them? Why would we go to air ejectors over a vacuum pump? If we already had something on the ship, why would we remove it and replace it with a system like this if we had something that worked just fine? What would be the need for that?
Is the system more efficient than the old system?
It's not just more efficient. It could have been. I don't know the exact efficiency between the two, but think about, and efficiency doesn't just have to be how much heat you're grabbing from certain systems. All right, it could also be how well the people who are operating the ship could be. All right, so air ejectors, remember, they don't have really any wear parts. They don't break. They just kind of function off of a Venturi effect with a prime mover that's going through it, and it has a drag line. All right, and then a cone. All right, they're great. They have no moving parts. But it could be a lack of efficiency. Right? A non-moving part that does the exact same thing is great. You don't have to repair it. You don't have to do any preventative maintenance. You don't have to do anything to it. If it breaks, it's like a $5 piece of brass that you stick into it, and it's up and running in probably an hour. But what else could be going on? What about vacuum pumps? Has anybody ever worked with a vacuum pump before? No? Okay. So vacuum pumps by their nature are extremely loud. All right. It's quite literally one of the loudest things in the engine room, and we are surrounded by turbines, steam, and boilers. All right. They are so loud that they would actually attract enemies, pretty much. You became a target. Especially in wartime, these things were basically attracted submarines to these vessels. That's how loud they were. All right, and that's in comparison to a main engine room. So the removal of those pumps made these ships super quiet. And that was one of the main reasons they got rid of them, and got rid of them quickly. All right. So we don't have a vacuum pump. We go through a main air ejector. All right. So our condensate is going to the first stage heater. Our first stage heater is not used anymore. It's actually just bypassed. All right. But we still have to learn about it. So we have condensate coming in. All right. From the air ejector, from our condenser. And it's not just traveling on a straight line like this. It's going through 3 different heat exchangers in one. All right. So we have our low pressure turbine bleed. We have our actual first stage heat exchanger up here. And then they go to the first stage drain cooler down here. And then we have our gland exhaust condenser. So where's the first stage heater located on board the TSES? Where's it located on the ship? Does anybody have any idea where the first stage heater is? So the first stage heater is located in the lower engine room. Remember, we have our door right here. All right. This is our door to the entrance to the lower engine room. We have our first stage heater is located right next to it. All right. And right next to that is our ADT, or atmospheric drain tank. Okay. So that's another thing, guys. You know, the big thing that, you know, it always is definitely that feeling at maritime where you learn some terminology just because they want you to learn it. You know, you feel like you're never going to use these things. But certain things like aft, forward, port, starboard, all right, decks, stuff like that, it's used in industry. All right. Make sure you guys always continuously remember where you are on the vessel. All right. Where you're going, whether it's on the port side, the starboard side, where if it's up forward, all right, where you're facing. These are terms that are going to be used in the industry. No one's going to be saying on the left side of the engine room. That doesn't make any sense to anyone. All right. Know where you are is important. Knowing if it's the inboard side or the outboard side to different pieces of machinery is very important. Especially when you're talking to someone outside of an engine room. All right. So let's continue on with the lesson. And we're going from our condensate. It's coming from a first stage heater, and it's now going to a DC heater, or a direct contact heater. All right. The DC heater is located where in the engine room? It's a giant tank. You can't miss it. Where is it?
Up high.
Say again?
Up high.
It's up high. Yep. Where specifically is it? Is it next to the boilers? Is it below the boilers?
It's in the uppermost part of the engine room.
So pretty much as high as you can get in the engine room. It goes in between a couple of decks, actually. So it'll be above the boiler. All right. And this is pretty much, you're on your top level. You'll actually be on a level. There's a staircase that comes up right as you go up to the top of the DC heater. And there's a deck that kind of goes all the way around it. And once you're on that deck, you pretty much have a ladder. And you're going into the stack. All right. That's how high in the engine room this DC heater is. And it takes up multiple decks. You actually will have, like, I think it's 3. It's 3 decks tall. All right. That's just going off of memory. So we have our condensate from our first stage heater. All right. This is where our condensate is going to be entering. Now, it goes into the top. It basically gets sprayed out. And then it gets hit by auxiliary exhaust steam. And what we're doing is we're trying to, like, whack out. We're trying to remove any of the O2 in the condensate, anything that might be entrapped in it. All right. The DC heater is also called a deaerating feed tank, or DFT. And the feed water is going to be at approximately 15 psig at 250 degrees Fahrenheit. Now, DC heaters are basically surge tanks. All right. If we're going to be using more steam, we want to have more feed water that's ready to go. All right, we don't want to take distillate and try and heat it up and bring it up to this pressure already and have to chemically treat it and all this other stuff. If we need steam, we want to be able to make steam quickly. All right, so, and then the vice versa is true. If we don't need as much steam, we want to be able to surge it. We want to be able to take in a huge amount of feed water and not have a problem where it has to constantly go into the boiler. All right. So this is going to go directly from here all the way down into the lower engine room, and it's going to go into the feed pumps. The feed pumps are right next to, as I drew in the picture, you have your feed pumps. All right, you go down shaft alley over here. You have your auxiliary condensers on the starboard side, and you have your 4 compressors. All right, your reefer compressors. All right, so we're going all the way from the top of the engine room down into these feed pumps. So all the way from the DC heater, we're going to our main feed pumps. They're turbine driven. We talked about during pump operation. All right, we have our suction valve. We have our turbine, which is 150 pound auxiliary steam. We open up our suction valve and we have 2 abilities. We have discharge of auxiliary feed and we have discharge of main feed. And the main difference of those 2 is what we're going to see in the next slide. But both will feed both your starboard, come on, and your port boiler. All right, so your main feed pumps already have a recirc also to the DC heater. All right, and as we go through, we're almost done, we're almost there with the whole entire thing. We go through our main feed and our auxiliary feed will join back up after we literally just split them. All right, but here's the main difference. We both have stop check valves and they both have stop valves. But our main feed line will have a feed water regulating valve, where the auxiliary does not. And then we're going just into the port boiler. We're going to talk about that. All right, and it goes to the economizer and it goes right from the economizer into the steam drum, and that will finish off what we have. But the economizer doesn't really exist right here. All right, the economizer exists in the stack of the boiler, or basically right on the edge. All right, it's not necessarily in the stack all the way above the DC heater. It's going to be located pretty much where all of the combustion gases. That's the last thing they're going to be touching before they go into the stack and then they get blown out of the top. All right. So our main line basically goes through. Oh, getting an echo. So here's that picture of that boiler again. All right, here's our steam drum right here. And like I said, it's not really in the stack, but it is in this section. This highlighted section is their economizer. All right, so all the flue gases that are happening right here, they go through our generating tubes, they go through our superheater, they go back through our generating tubes, and now they've pretty much used all of their energy, but it still has heat to give off, and now it's going to go through our economizer, and that economizer is basically just going to preheat all of this feed water. All right, and now that we look inside of this steam drum, this is a blown up version of it with some squiggles on it that I've drawn. All right. Now, this pipe right here that I just got highlighted, that blue pipe, that is going to be where the feed water is going to be entering into the steam drum. All righty then. Any questions on that? Because that is pretty much the entire steam water cycle in a nutshell.
Can you just go over the economizer again? I just want to make sure that I understand.
So remember, guys, the economizer is basically going to be, it's not really located in the stack, but it's basically just full of all of these different tubes that are going to be trying to grab as much heat that's coming off of these combustion gases. All right. So we are producing all this heat, and these combustion gases are giving off their heat. And as they go through all of these tubes, you have a temperature differential between the two. All right. And then right here in this economizer, you have the lowest water temperature. So you have a low feed water, low temperature. All right. And all the gases, all the combustion gases, they're not going to be as hot as what they were right here. They're not going to be as hot as when they went through the superheater. And they're not going to be as hot as when they go through all the generating tubes. All right. But you can bet it's going to be a lot hotter than this feed water temperature. All right. And that temperature differential is going to still allow us to have heat to be given off from our gases to go into our feed water, because we're going to basically right now we're trying to preheat the feed water so that way it goes into the boiler as hot of a temperature as we can possibly get, so that way we can produce our steam as quick as possible. All right. And that's what the whole point of the economizer is to do, is basically to try and just utilize as much of the heat that we produced as possible. It's all about managing our temperature, all about managing heat that we produced. All right. Does that make more sense? Okay, good. So now that we just have basically spinning turbines, we have to talk about how we're going to use that energy. All right. Right now, what we have up on the, basically up on the screen is we have a double reduction gear. All right. So we have a couple of terminology here. Right now we have this high-speed pinion here, and we have this pinion right here. And both of them have different labels to them. We have a high-speed pinion, we have a low-speed pinion. All right, and then we have these reduction gears. All right, a side view of what they would look like is basically a smaller gear attached to the bigger gear. And what you're trying to do in this instance is, if you have your reduction gear right here, and you have your pinion here, what's going to happen is that your pinion may need to rotate 10 times to get one rotation out of your main reduction gear. All right. And what you're trying to do is you're trying to take this high speed but low torque, and you're trying to convert it all into a low speed but a high torque output. All right. Because if you have a propeller, and the way propellers function is if they're just whizzing away at a high speed, it's not going to do anything for you. All right, especially on such a heavy vessel, they're not going to move. They'll just turn, and they're not going to move the water. They're not going to be able to produce the energy that's needed to move the vessel. But a low speed propeller with a huge amount of torque behind it is going to push the vessel. It's going to propel the vessel through the water. All right. And that's what we're after, is that high torque. All right. And now we have basically three bearings. We have our thrust bearing, our stern tube, and our line shaft bearing. All right. So which one of these is going to take the brunt of what's being produced at this propeller? Which bearing is actually going to be moving the vessel?
The thrust bearing.
So it's going to be the thrust bearing. All right. Even though these reduction gears and these turbines have huge nuts on them and huge bolts holding them onto the vessel, that's to keep control over our turbines. All right. That's going to keep control over these pinions because it's such a high amount of energy. But really, this singular spot is this thrust bearing is going to be taking all of the forces that are going to be applied to this propeller. It's all going to be transmitted down this line shaft, and this is the spot, the singular spot on the vessel that's going to be pushing the vessel through the water or pulling it into its stern. All right. take a look when you go onto the ship, is there's going to be, as you turn to go down Shaft Alley, just as you turn down, there is a massive, there's your walkway. There's a massive thrust bearing right here. And it's covered in nuts. It's like 2 rows of nuts about like that big, right? And that is to hold this thrust bearing to the vessel itself. All right. So we don't just have on our ship, let's before we go that. So what's the point of our line shaft bearing and our stern tube bearing? What's the point of these? Lost my pen. What's the point of those before we continue on? Why have them if this is going to be taking the thrust of the ship?
To hold the propeller in alignment.
So our line shaft bearing is to support the line shaft. It also holds in alignment. But what else? What about the stern tube bearing? What is that point? What's the point of that? What's on the other side of the stern tube bearing?
Seawater.
So right on the other side of it is our seawater. All right. As soon as you go through that stern tube, you are out at the sea. So this is the last thing. And of course it has to be a bearing, because if not, you would just have metal to metal contact and that would basically seize up. All right. So this is utilizing salt water, a small amount of it, to lubricate the shaft. And it's basically creating a seal to keep out all of the salt water. All right. So that's all of the bearings. And of course we have multiple of these line shaft bearings. We go all the way up and down the whole thing. But as we go through, we have our high pressure and low pressure turbines. All right. So we have double reduction gears. So we have our high pressure, high speed pinion. That's this thing right here. That goes into a high pressure first reduction gear. That is putting its energy into another pinion, and that's a high pressure, low speed pinion. All right, and that is going to go into a bull gear. And the same thing in the low pressure turbine. We have a low pressure, high speed pinion, goes into the low pressure first reduction gear. And the low pressure, low speed pinion goes into the bull gear as well. All right. So we have different ways and different things on board different vessels that will basically transmit different power the same way. So an electric drive, we have with gas turbines, but you can replace the gas turbine with diesel. You can replace the gas turbine with another steam turbine. All right. But what you're doing here is you're reducing the speed and you're trying to increase your torque so that way you can produce electricity. All right, so this gas turbine is going to spin at the same speed. So it's going to produce electricity no matter what is being asked of the motor to spin at a certain RPM. All right, so you can do a diesel electric drive, and this diesel could be spinning at 1800 RPM, which is what most generators are going to spin at. All right. And you'll have a motor that's only going to be running at maybe like 20 RPM. So it doesn't matter what's being produced by this generator with its RPM. What you're trying to do is produce enough electricity to move this motor. All right. And that's the same thing with the gas turbine. And that's the same thing as if you had like a non-reversing steam turbine. All right, where it's basically a turbine that's just going to spin at one speed in one direction. It's going to produce electricity, and that electricity is going to be used in the motor to move the vessel. All right. Any questions on any of that, guys? All right. So let's move on to the EOT. All right. The EOT is the engine order telegraph. And that's the big thing that you guys have to understand is that up on the bridge, they have their own EOT. And what they're doing is they're requesting a certain speed. They're not actually here. Not actually going to be controlling the vessel. All right. The vessel itself is not controlled directly from the bridge. They are asking the engineers to go and do a specific speed. All right. So when they put through an order, they are going to basically say, we want to go slow ahead, full ahead, whatever they want. They're requesting us. And they move their knob and it moves an arrow down on our end. We have to acknowledge it. And that's the big understanding that up on the bridge, they always have to understand as well. When we acknowledge it, what we are doing is we are saying, hey, we know you want this, but we're working on getting it. All right. And that's the big thing is that what we're saying to the bridge. One, we acknowledge what you want, but two, there's this really annoying bell that rings from the EOT, and we just don't want to hear it, so that's why we turn it off too. All right. So that's all we're doing. The bridge asks, and we say, hey, we're acknowledging that we're going to be doing this. All right. Give us a little bit, and we're going to get you to it. All right. So the biggest thing is that before we go into the bell book, is that we have our boilers over here. All right. And starboard. And with that,
How long would it actually take you guys to switch speeds?
how long?
Yeah.
So what you're going from and to. And
I guess full to half.
so full to half.
Not that drastic.
Say again?
Not that drastic, I guess. Just reduce speed.
So we'll talk about that in a second. I don't have exact times of like 5, 10, 15 minutes. But the thing is that there's a couple of things going on with that. All right. Now, let me just draw this out real quick. So right here on the screen, we have both boilers. We have the port and starboard boilers. All right. We have both turbines. I'm just keeping them as a box. All right. We have the throttle box with our stern. All right. And then we have our head. And then this little circle right here is our EOT. Engine order telegraph. All right. Now, this is the biggest thing is that, when you are going to be in this position, and it's a freshman position to be running the EOT. All right. It's a senior position to run the throttle box. So what the job of the person that runs the EOT is to acknowledge the EOT. All right. So when the bridge is asking to go from a half to a full, you're basically going to acknowledge it. You're going to write it down in the bell book. All right. And then the third thing that you have to do is you have to quite literally stand here, because you can't move from this position because they may ring something down. They might go from a full to half to a quarter. And it might be really quick. So what you have to do is you have to basically yell across the turbines to the people running the boilers. All right. And why do you have to yell to the people running the boilers? Why wouldn't you just whisper over to the people running at the throttle box? They're the ones controlling how much steam is going to our turbines. So why have to yell to the people running the boilers? What's the point of that? What are we doing when we go from half to full? So to go from half speed to full, what is going on? What happens in our engine room? And why wouldn't the bridge want to have full control over these throttle boxes? Why wouldn't we just give them a throttle box up on the bridge? What do we need to do? Think about the entire steam cycle that we just went through. What is going on? What's the first thing that happens? We open up this throttle box. What happens? All right, we're going to go from half to full. We start opening up and we letting more steam into the turbines. What goes on?
Do you lose pressure?
You don't really lose pressure. What's the simplest? What's the first thing that will happen? Don't overthinking it. Don't overthink it. All right. What would happen first? You open up this throttle box and you open up a valve to allow more steam to go through. You're going to start to use more steam. All right. A larger volume of steam is now going to go from the boilers to your turbines. So that's what you want. You want more steam so you can produce a higher speed. All right. But what else is happening? We talked about the DC heater as a surge tank. All right. So if we're going to be using more steam, that means we're going to be losing steam out of our boilers, right? But that's good. But here's the thing, is that boilers aren't going to be producing a same set volume of steam through its entire existence. They don't run just like generators run at 1800 RPM at constantly. We're not producing, 50 cubic meters of steam per second or what have you. That's not a normal rate of what we would operate with boilers. What we're going to be doing is we're going to be seeing how much water we have to add to our steam drum. So we have to manage our steam drum level. And then the other thing is that we have to turn on and we have to add what I drew down here as our burners. All right. So if we're at full steam, we need all 4 burners going. If we're at half, we may only need 2. All right. And that's something that we would be doing is we would be turning on burners, turning off burners, managing our water level. All right. Because if all of a sudden we have a huge influx of steam that's going to be pumping towards these turbines because they're going to want to go from this high pressure to this low vacuum, we need to manage that and we need to produce more steam. So we have to manage our water level. And that's why it's so important to yell across these turbines and yell to the people working the boilers. To go from slow ahead to full ahead is wildly different conditions in our boilers. It's wildly different conditions that are going on in our engine room. All right. So the question was asked, how long would it take to go from full ahead to even half? And the answer with that is always as it depends, because one, you're managing all those conditions that we just spoke about. But 2, to slow down or to speed up, we are also increasing or decreasing not only how fast our turbines are going, but also think about the momentum. Think about all of those reduction gears that we're going to be working with, the mass of material that are going to be moving that we have to slow down or we have to speed up. All right. And these are all things that are going to have to be considered. How fast is the vessel moving through the water? How much steam do we have at that point? Is there any problems that we're running into, or, all of these things are factors in it. But the one number I do know is that from going from full ahead, where we reached max speed, this happened on my senior cruise. We did sea trials. And so from max sea speed to full reverse. All right. And we went to full reverse. It took 10 minutes. Not before our turbines started spinning reverse, but it took 10 minutes before the ship went from full ahead and slowed the ship down enough through the water before we started seeing the ship to start going in reverse. 10 minutes is a very long time anywhere, whether it's the middle of the ocean, whether it's in a harbor, because if you need to go from max speed to full reverse, and before you even start to see the ship moving backwards is 10 minutes. Think how far you will travel in those 10 minutes. All right. So it's very important, like I said, that we have an understanding of what is going on in the engine room, and why I always talk about the fact that you guys who are in the deck department, who are taking 540 and everything like that, the understanding of what is going on down there will give you a better indication of how to be good bridge officers. All right. We arrived in the Azores my freshman year, and the pilot who was coming on board has never been on a steamship before. And he thought the EOT operated just like any other diesel ship he's been on, and he had direct control. So he was making crazy wild orders, like he was in a car trying to parallel park and he had full control over the vessel. All right. Bad things happened, and we had to manage a problem for the rest of the summer after he was on our vessel. All right. So, he went from full ahead to full reverse, half head, half reverse, and he was just wildly messing with the EOT through the entire process. All right. But the understanding of what's going on down there is the biggest thing. All right. But make sure you yell, or you'll get yelled at for not yelling loud enough. And then you'll learn how to yell.
With sea trials, aren't there certain times we have to hit?
I'm not sure what the times we had to hit with it. I think it was more of what they were doing was an experiment. They wanted to know the numbers. All right. Because it hasn't been done in a long time. Certain sea trials, what you do is you would have to have specific things you would want to hit, to do. Obviously, like I've done sea trials on board one of these vessels that I was on that needed to be certified to go from a manned engine room to an unmanned engine room. And one of those things is like, if an engine goes down, will another engine pick up the load? So we would manually trip one engine and another engine had to come back online. So certain things like that is what are predictable. But this, I think, was just to find out what would happen. Like what was the timing expected to happen? Okay. Like again, unfortunately, guys, I really don't know this. The other thing is that down in the engine room, we're rated our RPMs. We don't know knots. All right. So we operate down there with RPMs. So as you know, what we go from, if we're going from full ahead, full to half to us is RPMs. We achieve that RPM. We have no idea if the ship is moving at that speed or not. All right. So you also have to think about the timing of how long does it take this large vessel to go from, not only are we at its rated RPM, but also are we actually at the speed that we want to be at? All right. I was going to draw something there. Any other questions about this? All right, so before we have about a few minutes, we're going to get through the rest of this. I want to make sure everyone's perfectly clear before, if anything cuts out. Wednesday, we have a quiz. So it's on a quiz on what's going to happen is the rest of these slides. I think we're only going to get to slide 33 because the other class didn't get to pass the bell book and we went over by 15 minutes. All right, so quiz Wednesday is from where we started, which was slides, help if I wrote these things down. Quiz 3 is, let's go for this. This is easier. All right, so we went from slides 1 to 24, I believe, or 23 on the first quiz. Now, this next quiz on Wednesday is going to be slides 24. Let's call it 24 to 33. All right. So everyone's aware.
Can you repeat that, please?
Slides 24 to 33.
Okay.
And that's
Thank
going
you.
to be the quiz for Wednesday. All right. Now, then we'll continue. So Wednesday, as you see, we're pretty much done here. We're going to do the bell book and everything like that. We'll do that Wednesday. But let's see. We have our test 3 is going to be on manage participants. It's going to be on the 23rd. All right, Thursday the 23rd. We're going to go over that on Wednesday. Wednesday is going to be review, so make sure you come with questions. All right, test 3 is going to be hydraulics, electricity, and steam. After that, we're going to be going over some things that I think is important as far as the operations of the ship and just some keynotes that I think you guys should know about because unfortunately you guys missed a little bit of your mug year, which is usually the time that the IDOs will tell you about this stuff is within the last couple of weeks. Fortunately, but unfortunately, you don't have that. Fortunately, you don't have to walk to and from the bathroom in PT gear, but unfortunately, you lose some sort of technical knowledge from your IDOs. All right. So other than that, if anybody has any questions, I'll stick around for a few extra minutes, but you guys ended a little bit earlier. It said, make sure you come with questions for Wednesday.
When are your office hours tomorrow?
Let's see. It's from 9 till 12 and 1 till 3.
Okay.
If those
And
don't work, email me and we'll work out something that does, okay?
And it's in the Zoom email, one of the emails?
So if you go to Blackboard, it says office hours link. All right, if you click that, you'll basically just pop, I'll have a Zoom open. All right, so you'll just pop in and just basically like, nah, kind of mentality. You just have to act like it's, because you're just going to come in through my speakers. I'll have you minimized, all right?
Okay.
All right. Any other questions?
Have a good day, Professor.
Have a good one. Ishmael, you feeling all right? You there?
Hello, sir.
Yeah, I got your email. Are you if you're not like if you test positive or anything like that, let me know. All right, and we'll work out something for your test.
All right, sir. All right.
Okay.
Okay, sir.
So that way we can make sure that you're okay.
Okay, sir. All right,
So
sir.
keep me informed of what's going on, and of course,
Okay.
always doctor's notes and stuff like that.
Okay. All right, sir.
All
I'll
right.
do that. All
Have
right,
a good
sir.
one, and
Thank
get
you.
better.
Bye.
All right. No more questions. I'm going to end this.